Okay, so in this picture you can see, if I bring my camera close, that this marks 0. Now what we need to do is we need to bring this to this side and advance the table. You can see. Hello guys, welcome back to the channel and welcome back to another video. So in this video, this is a piece of aluminium which we are going to machine in our milling machine. Now this is going to be a machining video, primarily a milling machine video, where we are going to make a fixture plate for one of our customers who stays in Mizoram. Now usually, ideally, that part of our country do not have stocks of aluminium, so it has come to us where the customer requires a fixture plate. If you don't know what a fixture plate is, it is basically a kind of a setup where you drill multiple holes as per your convenience to hold stuff over this, and this becomes a sacrificial piece. So what happens is, you can make a lot of fixture or tooling to sit above this, and this becomes your kind of a table where you can clamp stuff for drilling operations, for milling operations, or facing, or any kind of grinding. Now the customer has requested for us to do this. It is going to be a very simple machining video. Now the stock which we have currently over here has a measurement of 25 millimeters odd. So it's a 25 millimeter stock which we need to machine it down to 21 millimeters, and the dimensions which they have provided is 12 by 9. So what we have ordered is a plate aluminium which measures a little bit more than 12 by 9. So here it is 9.5 and this is 12.5, so that we can clamp it on our milling machine when we are facing this. So the entire area, workable area, gets machined in a single pass, and then we are going to flip it and do the other end. I wanted this to be shared in our YouTube so that you guys can also see how we go about with the machining of this aluminium, piece of aluminium. So without wasting much time, let's get started. So we are cleaning the table now. We have kept the vise on one side, on that side, because we need sufficient area for that big piece to sit. But before we could go ahead and sit this piece, we need to indicate that this mill head is tram. Tramming means it is perpendicular to the axis of the table, the x, y and z axis of the table. So for that, this is just a dial indicator mounted on the dial indicator stand, and we have removed the stand for this purpose, and it is going to go in the quill. The reason why such is important, because if the milling head is not properly true, we will not be able to achieve the accuracy on the part. The part needs to be flat within 0.10 microns. That is usually a milling standard, and this milling machine is brand new, so it is going to give us good tolerance that we are hoping, if we don't goof up somehow. So we are going to show you how we are doing this. Okay, so in this picture you can see, if I bring my camera close, that this marks 0. Now what we need to do is we need to bring this to this side and advance the table. You can see that this is also 0. Now if we just rotate it another 90 degrees, here we can see that this is 0, and if we move it another, say, 90 degrees, it is very tricky to let you guys show because it is facing the opposite side towards the mill. But as you can see over here, this also marks as 0, which means our head is perfectly trammed. It is a good practice to check the tram of the milling head from time to time, because when we take hogging cuts on the milling machine, this head tends to move around a little. So because we are doing a facing operations and it is a large facing operations, for example, as you can see, it's a 12-inch long by a 9-inch long piece of 25 millimeter aluminum slab. Any discrepancy over the in the head will result in the work. We do not want any errors as such, so it is a good practice to check the milling head tramness from time to time. Okay guys, so what we want to show you is a 50 millimeter cutter that we have got some time back. Now we had got this during the Diwali last year 2024, and we showcased it on our channel. We didn't get much use out of it. This is the first time that this brand new cutter which came in this box will be used. It's a 50 millimeter 4-tooth cutter, as you can see, but the cutter itself won't fit on the milling machine until and unless we get a holder for it. And this is the holder which we have ordered recently from RR Tools. Yeah, so this is a brand new tool holder which we have ordered, which will go something like this. But before we do this, let's just use the inserts. Now these are a pack of 10 inserts that we have got, and this inserts fits like this, as you can see. One done, another remainder 4 to go. So 3 done, last 1 to go. Okay, so 4 inserts. Now let's use this tool. We need an Allen wrench. This is just a 50 millimeter tool, but it consumes a lot of carbide inserts. I got this pack of 10, and between this and those indexable end mills, we are just left with 4. Probably it's a good idea to reorder a fresh set of 10 pieces. Now this is the holder assembly, which we need to take out right now. Alright, I think this will just slide in. This is supposed to. They both are 22 millimeters. Yeah, it's just a very precise fit. And this is ground, as you can see. It's a 22 millimeter one. So it just fits in very snugly. A little bit of play, but that's all right. I think this is not the right way, is it? This is not fitting. Okay, the problem which is happening is, I don't know why, what is the use of this washer as of now, but this countersink, because this countersink head is a little wide, it's not going through the cutter, so it is not meshing with the threads. This is the M10 countersink bolt. What we have over here are 2 different sizes of M10 hex bolts, which passes through the head. So let's see which one fits. Now we are going to try the bigger one. So this is the bigger one right over here. I think it is going to work. Yeah. So all it needs to be is to hold it tight and be beneath the surface. So I think this setup is going to work as of now. So this is the cutter which we are going to use. So we are going to install the cutter. All right, and that in the drawbar. Now we need to raise the table up. For that, we are going to pump some oil first, and the second thing is that we are going to use some light spray oil. We use a can of WD-40 because that works good for us, and the reason why we are using WD-40 manually on the way is because this table we have not brought this up so much like we are going to do it now, because we never did milling over the table with a stub mill arbor. So the stub mill arbor is very shallow, and we need to bring the table up. The reason we are using WD-40 because it is a light lubricant, and the only reason that we are going to manually spraying it in, because we also have a pump we can use. We are using the pump as well, and we are using WD-40 spray. All right. So I guess this is as much as we can go. There is a bolt in the top which is hidden behind these bellow covers. I think we need to take that bolt off. I don't know why that bolt is present. Let me just examine the bolt. Okay, we don't know why that bolt is there in the first place, so we are going to take this out and see what happens. Okay, this was the bolt, same bolt, M10. So now we think that we can crank the table all the way. The reason why we are cranking this all the way is because in this entire machining operation we want to use the table rather than the quill. We are going to lock the quill. The reason why we are doing so, because the quill can sometimes move, but it is very hard to move the table. So, and we are going to lock the table after each and every pass, and I think this is going to work well for us. Here if you see, we are just going to crank the table up so high. I think we will have enough travel, so travel is not an issue. Alright, so we are going to bring this in, and we are going to start with the machining. Let's start the machine. And before we start the machine, we are going to ensure that this is all tight and it's not going to go anywhere, because if this material flings, it's a 5 kilo material, it is going to whack me straight in the eye. So we want this thing to be tight for our own safety as well. This is tight enough. So first what we are going to do is we are going to ensure touch off. Okay. So, and we are going to mark this on our knee as 0, which you can see right over here. This is the knee. We have marked it as 0. So we are going to give a depth of cut of 0.5 millimeter. So this is 0.5, and here we are going to lock the knee. And we are going to go with a cut. I hope it is visible on the camera. So let's start. So this thing is taking a cut now. We are going to use some kerosene to lube the cut. Okay. So this is the second cut we are giving. I believe the finishing is coming great. The tool is locked in place. So we are trying to just manually cross this strap clamps that we have. Alright, so we believe the outer periphery of this part is machined. The machining quality looks good, but still we are going to use some kerosene that we have, because kerosene or WD-40 makes for a very good cut in aluminium, and because WD-40 is expensive, we use kerosene. Alright, so this marks the end of our cut. We just need to see how much we how good we did, and for that, so ideally it was 25 millimeters to begin with. Now we have taken 0.5 millimeter off, so it should technically be 24.5. We need to check. It's showing a little bit more, 24.14. So let's give another 0.5, or rather check it in two different spots. It's 24 millimeters it is showing. Yeah. So we are down to 1 millimeter. When we have given 0.5, we don't know why, but maybe the subsequent pass will make it more precise. We have to bring this down to 21 millimeters on both ends. So we are going to go another millimeter, 1 millimeter over here, and then we are going to flip the part. But before we do anything, let's just clean the surface area. Okay, so the surface finish seems very good to us, but we are still not sure why we are getting this 0.5 millimeter discrepancy. So what we are going to do is we are going to go ahead with another cut and see if the results are consistent enough. Then we can see what we can do next to prevent the situation. So we are going to go 0.5 and make it 1 millimeter. So this is 1 millimeter depth of cut. It's not 1 millimeter depth of cut. 0.5 millimeter depth of cut. Overall 1 millimeter thickness reduction. Like last time, we are going to use some kerosene. So we are going to check the thickness. So let's check the thickness on this end, because this has already been machined, and we can see that this is 23 and a half. Bingo. Because we are measuring this on a vernier caliper instead of a micrometer, so we are going to give 0.05 millimeter slack, and that is okay with us because the accuracy that the customer requires is 0.10. So we are within the tolerance, and this might have resulted is because this knee handle is connected to a gib, and when we tighten any gib, it becomes straightened parallel to the axis of the machine. And because when we have initially touched down on the part, the knee was unlocked or the gib was not tightened, and when we have given our depth to 0.5 and we have adjusted the gib and made the gib tighter, it moved the table 0.5 millimeter odd or something, that resulted in a 1 millimeter depth of cut instead of 0.5 millimeter. So we are within tolerance now, so we can proceed with the cut. We are going to check few more times during the cut. I I believe this is going to be the final pass on this side. If it is 23.5, we are going to window the part and do the other end. So this side is also proper. Okay, this side measures 23.55. This side measures 23.70. This side measures 23.80, and this side measures 23.59 or 55. So clearly this side is a little bit higher than this side. We need to figure out why that is. So could be because of some underlying parts, but we are not sure. Though we have some materials to take off, we are going to window the part. Before we window the part, we have to remove this strap clamps and mill the area which has been left behind because of the strap clamps. And we are going to window the part, and we are going to see why that is, and if we can resolve the problem, because this needs to be flat and parallel within 0.10 micron. So today already it is quite late. It's close to 11:30 now, or rather past 11:30, 11:45. So we are going to come next morning, and we need to think about this over a cup of coffee, and we are going to hopefully find a resolution to the problem which we are facing currently. So we'll meet you next morning. Hey guys, good morning. It is the next day. So last night I thought that maybe the discrepancy which we are getting is only because we are currently measuring this machined face with the unfinished face. That is, this side is machined, the other side is not machined. So the discrepancy of 0.25 millimeter which we are getting probably might result because the other side is not a machined surface. So that side probably might be 0.25 higher or lower in various places. So this is what we could come up with. So the only way to find out is when we window the part and do the other side. But before we can do that, we have to machine the places where there are tabs. So we have to reorganize this. I show you. And before we can window the part, we have to machine the tabs below where there is this rest. So we have to reorganize these clamps, strap clamps, so that we can machine these two sides. We will show you once this is done. So alright, we are done with the reorganization of the clamps, and I don't know if you can see clearly in the picture. Alright, so this could be considered as 0. This is our touch off. Okay. All right. Okay, so we are using this scale as a parallel just to check if the surface is high. We don't think the surface is high, and it is done. So now what we need to do is we need to indo the part. So we bring down the table a little. This much is going to work fine. All right. So before we are going to indo the part in the milling machine, we want to debug the edges because these edges might. So this is the surface finish which came. We are quite happy with the surface finish. It might look that there are different steps, but we cannot feel anything. So it's just the marks because our cutter is definitely cannot be as big as a 12 by 9. We are happy with the surface finish which we achieved on this side, and we are going to indo the part and do the other end now and flip it and make it into a complete 21 millimeters. So once this thickness is done to 21 millimeters, we can go ahead with the milling of the sides to make it 12 by 9, because currently it is a little bit bigger than 12 by 9. It measures close to around 12 and a half by 9 and a half. As probably I have mentioned before, we have got an oversized piece because we need to machine all 6 sides. That is roughly. So with that said, guys, we will continue this in a different video. So thanks a lot for watching. We'll meet in part 2 where we will continue with this. Keep smiling. We'll see you in the next one. Thanks a lot.